All right, so today we're going to talk about solving equations with radicals in them. And it fits a little bit here in our rational exponent conversation because now that we know how to handle rational exponents, we can sort of explain why we do what we do to solve an equation with a radical in it. So we're going to talk about how to do that. And we're also going to talk about extraneous solutions, right? What an extraneous solution is and how do we go about looking for it. And that's where we want to start. So we also want to be able to solve radical equations. We're going to isolate the radical and then raising it to a power. We'll talk about why that works. First of all, an extraneous solution is basically an answer that's not an answer, or it's a solution that doesn't work. Okay? We know that a solution is a value of a variable that when you plug it in back into the original equation, makes that equation true. Right? Well, sometimes when you solve an equation, you get an answer, what you think is a solution, and you plug it back into the original equation, one of two things happens. Number one, either it doesn't work in the equation for whatever reason, doesn't make the equation valid, or two, it gets us into a position where we're having to do some improper mathematics. Right, and I'll talk to you a little bit about what I mean by that in just a minute. So, we have to start checking our solutions more now than ever before because it's possible that some of our solutions will end up being extraneous. Okay? Okay. So let's dive in. And before we get to solving this equation, right, let me ask you, and something that you should have seen before is, if I wanted to eliminate the square root, if I had the square root of x, and I just wanted x, right? One thing that we know that if you have x squared, to take x squared to x, you'd square root, right? And so this is going to be just x. Well, the opposite should be true as well. And it is. Here's why. If I were to square this, right? Or even before I do that, if I were to rewrite this with a rational exponent, it would be x to the 1/2, right? Now, if I square this, I know that my exponent rules say I need to take that exponent times that exponent. 2 times 1/2 is 2 over 2. 2 over 2 reduces to 1. X to the first is just x. So now I have gone from the square root of x to just x, and I did that by squaring. Okay? And the rational exponents help us explain why that works. Now, the same thing would be true if it were a cube root, right? If I raised it to the third power, I could rewrite this as x to the 1/3 to the third power. Multiply these guys and you get 3 over 3 or 1, right? So you get just x. The moral of the story is to eliminate a root, you have to raise to the same power, right? So a fourth root you would raise to the fourth power. The fifth root you'd raise to the fifth power. And the rational exponents explain why that works, okay? But that's what we need to do in order to solve our equations. Okay, so going back to, our original equation here. Shoot, hold on just a second. Okay, sorry. So let's get back to the original equation here, right? So here's what we got. And we just talked about, so we want to isolate the variable x. We want to get x by itself. So we just talked about, okay, well, we can eliminate the square root, and we have to get that x outside the radical so we can get it by itself. So to eliminate the square root, we can square both sides, right? We can square that radical. Well, in an equation, that means you have to square the entire side on both sides, okay? And that's a bit of a problem because squaring this is very complicated. It's going to end up requiring us to FOIL out a binomial this plus sign means we've got two terms here that we're going to have to FOIL out. And so that's a bit of an issue. And not to mention it will not allow us to get rid of our radical. So there has to be an easier way or a better way. And there is. I'm still solving the equation. So I can still subtract the same thing from both sides, divide both sides by the same thing, and it not change the solutions for my equation. So that's what we're going to do. We're going to subtract 6 from both sides. Divide both sides by 5. Now we've got a situation, if I square this side, then I'm just squaring I'm just squaring the square root. And so I have to square the other side at the same time. But what that means is I'm basically eliminating the square root. The square and the square root eliminate each other, and we just get x plus 3. This is 16. Subtract 3 from both sides. And so x is 13. Now, we talked about extraneous solutions. Extraneous solutions are solutions that aren't really solutions, because when you plug it back up into the equation, it doesn't work. So we've got to get in the habit, starting now, of checking all of our answers. Not just to make sure that we're right, but to see if it's possible that we get an extraneous solution. Right? Subtract 6 from both sides. Divide both sides by 5. And then square root 16. And it works. You get a situation where the equation is true. The other thing we have to be careful of, especially since this is a square root right here, is to make sure that when we plug our x back in, we're not getting negatives inside of that square root. That leads to imaginary numbers, and we want real solutions, right? So that's something else we want to look for, and didn't happen here. So x equals 13 is definitely a solution, okay? All right, a little bit quicker this time with a little bit less conversation. Okay, so bottom line is we want to get the radical by itself and then raise that to whatever power we need to eliminate the radical. That's the bottom line. So here we need to subtract 7. Bring down that minus sign as a negative. Then divide both sides by negative 2. Now, we've got the radical by itself. We want to raise this to the 5th power. That way, the 5th power and 5th root eliminate each other. We get 2x plus 3. 1 to the 5th power is just 1. Now we subtract 3 from both sides, divide both sides by 2, and x is negative 1. Okay, now we got to check it, make sure that it's not going to be an extraneous solution. The first thing we need to look is to see if we're going to get a negative inside the radical. Well, as a matter of fact, for this one, it's an odd root, 5th root, and so a negative inside of a radical does not lead to us having imaginary numbers. So we don't even have to worry about negatives inside the radical on this guy. So 7 minus 2, 5th root of 2 times negative 1 is negative 2. Negative 2 plus 3 is 1. So we go 7 minus 2 times the 5th root of 1, which is 1. And then we go 7 minus 2. And then 5 equals 5. So this works. Negative 1 is definitely a solution. Okay? But getting in the habit of checking. All right. Try 3 on your own and see if you think you got it. Stop the video, start it back up, and see if you're right. Okay? So there you go. You have to get the radical by itself. Add 11, then divide by 3, and you get this. Get the 4th root of x minus 5 equals 3. Then we got to take the 4th power of both sides. The exponent and radical eliminate each other. We get x minus 5 equals 3 to the 4th, which is 81. Add 5 is 86. And you can see where I checked my solution over there. It is not an extraneous solution, so we're in good shape there. Okay? All right. Next, number 4. We want to get the radical by itself. The problem here is there's 2 radicals. And if we try to, again, if we try to just square this side, this is two terms, right? That minus sign means that there's two terms here, which means we're going to have a binomial and we've got a FOIL. And if we FOIL, we're not going to get rid of the radicals the way that we want. So we can't just do that. But if I add 2 square root of x to both sides, and I'm allowed to do that because I'm adding the same thing to both sides, I'm not changing the solutions, then we get this. And now we only have one term on each side. That means when I square these, I don't have to worry about foiling. Okay? So I can actually eliminate the radicals. The square and the square root will eliminate each other. Here you got to be careful. If I were to rewrite this with rational exponents, I'd go 2x to the 1/2 and then raise that to the second power. We have to understand that 2 has its own exponent. So we would distribute the squared there to both of those exponents, giving us 2 squared x to the first, right? 2 squared is 4. In other words, because that 2 is sitting outside the radical, we have to apply or extend that exponent to that number. Okay? So we get 3x plus 2 equals 4x. Subtract 3x and x ends up being 2. Okay? A quick extraneous solution check. So we get square root of 6 plus 2, square root of 8, square root of 8 reduces to 2 square root of 2, and we get 0 equals 0, so we're in good shape. X equals 2 is the solution. Okay? All right. Try another one here. Okay, kind of more of the same. Go ahead and work this out. Stop the video, start it back up, and check and see how you're doing. And there you go. Hopefully you got 14 over 25. When you plug that back into the equation, it is going to work out fine. It's not going to be an extraneous solution. So we haven't come across one yet. But you do have to continue to check. You never know when one's going to pop up. Okay? I'm going to walk through some more examples with you, and hopefully you can work a little bit ahead of me and check your work as you go. Okay? But I'm just going to work through these examples with you. Next one here, again, 2 terms because of that minus sign, so I'm going to add 4 square root of x to both sides. The square root of 36 minus 2x equals 4 square root of x. Square both sides, and we're going to get 36 minus 2x. And then we can square the 4. We have to square the 4 since the 4 is sitting outside. The square and the square root here are going to eliminate, and so we get 16x. Right? Add 2x to both sides. Then divide by 18, and x ends up being 2. Okay? Again, plug back in and make sure that this works. 36 minus 2 times 2 is 4. Minus 4 square root of 2. We got 32. Square root of 32 minus 4 square root of 2. And then if you reduce 32, you get 4 square root of 2 minus 4 square root of 2. This solution works just fine. So the solution is 2. Okay? All right. Now, number 7 offers up something that's a little bit different, so I'm going to stop and talk to you a little bit more about how to work number 7. So again, we got to be able to get the x outside of that radical. Yeah, I know what you're saying. There's an x over here, and it's already solved for, and that's great, but it's not a numerical solution, so that's what we're looking for. So I've got to approach this the same way. I've got to get the radical by itself, so subtract 4. And then square both sides. Now, here's the next thing I know you're thinking, right? All right, x minus 4, we're going to have to double distribute, but we didn't want to before. We didn't want to before because we were double distributing with a radical. Here we're not. So we are going to have to take x minus 4 times x minus 4. Right? It's not just x squared plus 16. It's not how that works. You've got to double distribute. So you get x squared minus 4x plus 16 equals 2x. Combine those, you get x squared minus 8x plus 16 equals 2x. Subtract 2x from both sides, and you're going to get x squared minus 10x plus 16. Now, this is a quadratic equation, and the reason why I subtracted 2x from both sides, it's a quadratic equation, which means that we're going to try to use the square root method, the factoring method, or the quadratic formula, but none of those work unless the equation is equal to 0. Okay? So I had to get it equal to 0. Turns out x squared minus 10x plus 16 will factor into x minus 8 and x minus 2. The zero product property says that we're going to take those two factors and set them equal to 0 and solve for x. At this point, I hope we're able to recognize that the solutions are going to be 8 and 2. Now, there's 2 we've got to check. So you plug in 8. And you get 8 equals, 2 times 8 is 16. The square root of 16 is 4. So 8 equals 8. We're in good shape. So x equals 8 is a perfectly valid solution. Check the other one. 2 equals the square root of 2 times 2 plus 4. So 2 equals the square root of 4 plus 4. 2 equals 2 plus 4. Uh-oh, 2 equals 6? That's not right. That means that this guy must be an extraneous solution. As long as we solved it correctly, and we did, x equals 2 is going to be an extraneous solution. So make sure that you write that out and let us know that that guy's extraneous. Okay? All right. More of the same here. I want to get the radical by itself, so I'm going to add 2. So we get x plus 2, and then the square root of 2x plus 28. Then we got to square both sides, which means I'm going to have to double distribute the x plus 2. The square and square roots over here eliminate each other. And so we get x squared plus 2x plus 2x plus 4 equals 2x plus 28. So x squared plus 4x plus 4 equals 2x plus 28. Subtract 2x and subtract 28. You get x squared plus 2x minus 24 equals 0. And now we want to try to factor. And this will factor into x plus 6 and x minus 4. Which means that when we set those two equal to 0, we're going to get negative 6 and 4 as possible solutions. But we do definitely want to check, right? So negative 6 equals negative 2 plus the square root of 2 times negative 6 plus 28. So we get negative 12 plus 28. 6 equals negative 2 plus the square root of 16. 6 equals negative 2 plus 4. 6 equals 2. That's not right. So that must mean that x equals negative 6 is extraneous. Okay? Gotta check the 4. So just because the negative 6 is extraneous doesn't mean the 4 can't be. So 4 equals negative 2 plus the square root of 2 times 4 is 8. 8 plus 28 is 36. And so we get 4 equals negative 2 plus 6. And it does work. So 4 is a solution. Negative 6 was our extraneous one. Not that we have to have one, but okay. All right, another one. Go ahead and stop the video, try to solve it. Start it back up and check your work. Had you gotten to here? And now you're stuck, right? Because it won't factor and we can't use the square root method. That means that we have to use the quadratic formula. So we're going to get 10 plus or minus the square root of 100 minus 4 times a, which is 1, so 4 times 1 is 4, times c, which is 9, which is 36. Hang on a minute. Hold up. This actually will factor into x minus 9 and x minus 1. What am I doing? All right, well, I got a little excited about quadratic formula. Now I'll have to use that here. All right, so our two solutions apparently are going to be 9 and 1. And we got to check. 9 minus 3 better equal the square root of 4 times 9. This is 6. This is the square root of 36. 6 equals 6. 9 works just fine. How about 1? 1 minus 3 equals the square root of 4 times 1. This is negative 2. Negative 2 equals 2. I don't think so. So 1 is extraneous. Okay. All right. More practice. Stop the video, try 10. Start it back up and see if you're right. All right. Did you find negative 6 to be the extraneous solution and negative 3 to be an actual solution? Okay, there's the work that's involved there. You can pause the video now and check it out if you need to look at it in more detail. Okay? All right. Next one. Got a couple more problems here. Again, stop the video, work it out, start it back up, see how you did. And did you get this? So, negative 1 ends up being our extraneous solution. And 6 ends up being our actual solution. Okay? All right. One more quick thing. Story problem, a little bit. We have a formula. We're just going to plug some numbers into our formula. The strings of guitars and pianos are under tension. The speed V of a wave on the string depends on the force tension F on the string and the mass M per unit length L according to that formula. So let's say that a wave travels through a string with a mass of 0.2 kilograms at a speed of 9 meters per second and is stretched by a force of 19.6 newtons. Find the length of the string. Okay. Well, we have our formula. The mass here is going to go there. The speed, 9 meters per second, is going to go there for V. And the force of newtons is going to go right there. So just plug it in some numbers, easy enough. 9 meters per second, square root of 19.6 L over the mass 0.2. And this is the equation that we have to go solve. All right. Well, we can divide the 19.6 by 0.2 and get 98. Okay, and then to solve for L, we've got to square both sides to get that guy out from inside the radical. And now divide both sides by 98. So L is 81 over 98. Now we don't want to leave that as a fraction because that length doesn't make any sense. So we do want to divide it out, and the length of the string apparently is 0.827 meters. Okay? All right. Good. That's it. Homework's out in Canvas. Make sure you get it knocked out.